This video will show you how to solve problems involving dilations. Here is a figure. If I make the figure bigger, does it change shape? How about the measure of the angles? Do they change? We know that the side lengths change because it got bigger, but the angles still look the same, right? Let's check. Here are the angle measures of the figure, and here are the angle measurements of the dilated figure. The angles do stay the same, even though the figure got bigger. This is an example of a dilation. A dilation is a type of transformation that changes the size of a figure but not the shape. A dilation can make an object bigger or smaller, but the angles remain the same. Now take a look at the side lengths. Let's say our figure has the following side lengths. Here are the lengths of our larger dilation. What do you notice about the proportions of corresponding sides? They are all the same. All of the side lengths are twice as big in the dilated figure. This dilation would have a scale factor of 2. The scale factor is the image length divided by the pre-image length. You can use any set of corresponding sides to find the scale factor. In this case, use the bottom line. So the image length is 8 and the pre-image length is 4, which gives you a scale factor of 2. This tells you that the new figure is twice the size as the original. What would the scale factor be of the smaller image? Find the values of any corresponding sides and find the proportion. The scale factor of this dilation is 1/2, which means the new figure is half the size of the original one. If the scale factor is greater than 1, the image gets bigger. And if the scale factor is between 0 and 1, the image gets smaller. To perform a dilation, you need an object, a center of dilation, and a scale factor. In this example, the scale factor is 3, which means the dilated figure is going to be 3 times the original one, and that the vertices of the dilated figure are going to be 3 times farther from the center of dilation. The first step is to draw lines that go from the center of dilation through the vertices of the original figure. Now you want to measure the distance from the center of dilation to point X. Call this distance A. To find X prime, you need to travel 3 times that distance from the center of dilation. So travel 3 A's and place your point X prime. To figure out where to place Y prime, measure the distance from the center of dilation to Y and call it B. Then travel 3 times that distance and draw Y prime. 3 times the distance from the center of dilation will show you where to place Z prime. Now you can draw your new figure, which is 3 times the size as the original one. Notice, it is the same shape with the same angles, just a bigger size. These triangles are similar, but not congruent. What do you think would happen if the scale factor was 1/2? Now you want to find half the distance from the center of dilation to each vertex. Use a ruler to find half the distance to point X, which would be right here. Draw X prime at the halfway mark. Do the same for Y prime and for Z prime. The dilated image will be half the size of the original. As with all dilations, the triangles are similar but not congruent. Okay, let's try a couple of dilation problems. Consider the figure on the coordinate plane below. Draw the correct image after dilation of scale factor 2 from point -3, 1. First, draw your center of dilation. Draw a line that goes through the center of dilation and one of the vertices. Measure from the center of dilation to the vertex. Since the scale factor is 2, measure twice that distance from the center of dilation. And place your new point. Do the same thing with the next vertex. Draw a line that goes through the center of dilation. Measure from the center of dilation to the vertex. Measure twice that distance and place your point. Continue the same process for all of the vertices. Draw your lines to make the outline of your dilated figure. But notice that we still haven't done the line segment on the inside of the figure. To draw these lines, continue with the same process. Draw the line from the center of dilation through the endpoint of the segment. Measure and place your point. Do this for the other end of the line segment. And now you can connect the points. Before you finish, do a quick check by comparing the figures. Are the shapes similar? Do they have the same angle measures and the same shape? They do. Does the dilated figure look twice the size as the original one? It does. So this problem is complete. When the center of dilation lies on the same line as the figure, something interesting happens. Here is the original triangle, and here it is dilated by a scale factor of 1/2 and a scale factor of 2. What do you notice about the top line of all the dilations? They are on the same line. But why? This didn't happen with the other examples. The reason is because our center of dilation is also on the same line. Using the same figures and scale factors, notice what happens when I drag the center of dilation around the plane. Every time it's in line with one of the lines of the original figure, all of the corresponding lines end up on that same line. Consider the image on the coordinate plane below. The figure will be dilated by a scale factor of 1/2 from the center of dilation 3, -3. After the dilation, which lines will lie on the same line as their pre-image? Remember that the lines that are in line with the center of dilation will remain on that line even after they're dilated. Can you draw a line from the center of dilation through any of the lines in the figure? This line goes through some of them. So the lines AB and CD will lie on the same lines after they're dilated. Let's dilate the figure just to double check. Here it is after a dilation of 1/2. Notice that the lines continue to lie on the same line as their pre-image. This is because they all lie on the same line that goes through the center of dilation. Try one more problem. Consider the image on the coordinate plane below. The figure will be dilated by a scale factor of 3 from the center of dilation -3, -2. After the dilation, which lines will lie on the same line as their pre-image? So can you draw a line that goes through the center of dilation and a line of the figure? This line does. So your answer will be that the line E'D' will lie on the same line as its pre-image. Here is a dilation just so that we can double check. As you can see, the line E'D' lies on the same line as its pre-image. Distance is a good example of dilation. When you look up at the night sky, the dot of light from a star is actually a dilation of a gigantic star far away in our galaxy, and you are the center of dilation. So in review, dilations change the size of an object but not the shape. To perform a dilation, you need a center of dilation as well as a scale factor. The angles remain the same and the sides grow or shrink proportionally. Happy solving!